Hello, today we would like to talk about sustainability in automotive. But first, let us introduce ourselves. I am Chambost, Business Development Manager for Exterior Applications.
And my name is Krabbenborg, Business Development Manager for Automotive Interior Applications and responsible for promotion of our sustainable activities in automotive industry. Ineos Styrolution is the leading global styrenic supplier with focus on styrene monomer, polystyrene, standard ABS and styrenic specialties. With more than 3,100 employees and 16 production sites in 9 countries, we are the largest styrenic supplier in the world. We have set 2 ambitious goals to make the shift to a low-carbon circular economy. Our first goal is to achieve net zero emissions by 2050. In order to reach this goal, we have set ourselves a roadmap with an intermediary milestone to reduce our Scope 1 and Scope 2 greenhouse emissions by 45% by the year of 2030 compared to 2019. Our second goal is to sell 500 kilotons of eco products in 2030. With this, we hope to provide our customers with sustainable products that live up to their premium quality expectations.
The most important megatrends in automotive are autonomous driving, battery electrical vehicle, hydrogen fuel for motive power, connectivity and human-machine interface, as well as shared mobility. We foresee that car interiors will take center stage as buyers focus on the cabin experience. A car interior and the accompanying cabin experience are 2 of the most important vehicle differentiators in the future. Vehicle brands are not waiting for the next production start of a vehicle, but rather for the next operating system update. Consumers discuss car comfort level rather than acceleration and horsepower. This will transform how OEMs make and market cars. The rapidly evolving megatrends, automation, connectivity, electrification, and shared services will change the configuration of the cars and allow vehicle occupants to enjoy new and enhanced experience.
Sustainability in the automotive industry is a huge challenge, not just with regards to carbon emissions levels, but also on increasing recycled content in the near future. Reduction of carbon footprint is an important challenge that every industry is facing. Connected to this, alternative energy sources like electrical batteries or fuel cells are currently being developed and produced. Waste reduction is another critical factor. A new legislation for end-of-life vehicles is in preparation and is expected to be implemented soon. Automotive OEMs are aiming at increasing the content of recycled plastics to more than 20%. To help our automotive customers to reach this goal, we have developed mechanical recycled styrenic products that are already commercially available now.
In our specialties portfolio, we offer Novodur Eco with mechanical recycling content and Luranes Eco with bio-attributed renewable feedstock. Luranes ASA can be mechanical recycled, but there are no or limited recycled materials available for Luranes ASA. We expanded our bio-attributed offerings to include Novodur Eco. For all Eco product line, we aim to offer grades based on advanced chemical recycling in the next years. ISCC certification is used for bio-based feedstock and chemical recycling in the future. Now we can offer mechanical recycled Novodur ABS certified according to Recyclas and EU Third Plus, using post-consumer recycled ABS from used electronic household machines.
During various molding trials with Novodur Eco, we learned that Novodur Eco can be processed like fossil-based ABS with standard process equipment and tools. Similar process stability and part dimensional stability has been observed for both interior and exterior parts. Interior part examples were in many cases covered, but also uncovered, grain parts showed good surface quality. Examples are rear light housings, a grained and mold in color interior pillar, and an exterior pillar insert. These parts showed similar mechanical performance, good and stable surface quality even after aging, low emissions and excellent paintability. Many colors can be matched, but deep black and very brilliant colors are somewhat complicated to be achieved due to the grayish base color of the post-consumer recycled ABS. Erik, how are we producing these mechanical recycled grades?
For Novodur Eco MR, mechanically recycled grades, Ineostar is using ABS scrap from collected electronic equipment and housing, which is shredded into flakes and compounded into pellets. These pellets are clean and free from metals, flame retardants, and all other polymers, providing high purity post-consumer recycled ABS, which is compounded with modifiers and additives. For automotive applications, Novodur Eco is available in three types: Novodur H605, H801, H106. The properties are similar to pure fossil-based Novodur ABS. To meet high heat properties, post-consumer recycled content is between 30 and maximum 40%. Certified by EU Third Plast and Recyclas, and providing VICA value over 100 degrees. MSDS, IMDS, and GADSL statements are available with a comment that this material contains post-consumer recycled ABS. Unlike conventional materials, the recycled ABS is subject to compositional fluctuations that naturally come with post-consumer waste. Therefore, we perform repeated batch analysis on each source of recycled material before we decide which material to be used in our product. Furthermore, we test our raw material on a regular basis to check that remain compliant.
As I stated before, mechanical recycling is not always possible. For example, for Lorenz, as there is no reliable post-consumer waste so far for ASA. Instead, we offer bio-attributed feedstocks that comes with a significant reduction in carbon emissions. We have the Lorenz 778T as B30, which means 30% of the material is bio-attributed, resulting in a reduction of carbon emission of 40% cradle to gate. Furthermore, we offer Lorenz 777K as B50, so 50% bio-attributed content, which leads to a reduction of up to 60%. Our calculations for the reduction of the carbon footprint have been externally audited and verified.
Now you may ask, how does bioattribution work? In short, it's very much the same than green electricity. There cannot be dedicated plant for fossil-based and bio-based feedstock. Instead, both are used in the same plant and amount are tracked so that the amount of bioattributed material sold corresponds to the amount of bio-based material. This is monitored and certified by ISCC, a well-established sustainability certification system. As the final product is chemically identical to the fossil-based grade, you have a significant reduction of greenhouse gas emissions. That does not compete with land use, and yet there is no compromise in performance, no new product development or adaptation of process or technology, and no new registrations or regulatory approvals needed. Thanks for listening.
So good afternoon to all the auditors. Feel free to raise questions if you want on any topics, and we will be pleased, Frank and myself, to try to answer.
To reply on your questions. My cameras. Okay, no, it's fine. Are there no questions from the people seeing this live stream? Erik, can you hear me?
Yeah, perfectly,
Oh,
Frank. Yeah.
okay. But I don't see the questions, Katja, to be honest. Do I have to do here something?
Okay, so we've got some.
Erik, do you see the question?
Yeah, I see the question. So the question is about the source of for the mechanical recycled ABS. So as a source are coming from the W3E, if we have eco extrusion grade available. So yeah, up to now, we in the portfolio we have no dedicated eco extrusion grade produced by mechanical recycling. But I mean, this is probably something that we should think about in the future if it makes sense to go in this direction. Yeah.
But dus, Erik, we have Terloan GP22
Exactly.
Eco.
For
Okay.
for extrusion, it's yeah. Let's see if. Okay. Another question is about if we make 100% recycled ABS material.
100%.
Mm-hmm.
We don't, yeah? Erik, should I reply the question or you want to do that?
No, but it has been, you have replied.
Okay, that's okay.
That's okay.
I don't see the questions, that's the problem.
Yeah. So there are no. Are there other questions? In any case, you can reach out ourselves after the webinar if you want to raise more dedicated questions. Feel free for that. Okay, we have two questions now, which are the first one is regarding again the 100% recycled ABS material. Are we planning to do that in the future? And yeah.
Nou ja, the 100% recycle is always, mechanical recycling, of course, is technically a challenge, yeah, to meet impact and heat properties for automotive. And therefore, it's always good to have some virgin material in there to make the material meet the requirements in terms of feed cut and impact. If you only have 100% mechanical recycling, you always have a drawback in properties, but also long-term heat aging effects.
And another question is about how we to remove the FR additives from the ABS waste.
Nou ja, we have 2 or 3 or 4 selected service suppliers who are, let's say, sorting out the ABS and removing metals, materials which contain flame retardants, and also other polymers which are not part of we should not be part of the recycle stream. As soon we detect brom or chlor, it will be removed from the recycle.
Just to add something regarding the fact that we are not going to 100% recycled ABS material. This is also I would say on purpose, because we are aiming to propose a drop-in solution. So the idea behind our product is to be usable in the same application and with similar processing conditions compared to a virgin material. And this is more complicated, more challenging if we are seeking to go to 100% recycled ABS.
Any more questions related to mechanical recycling, our bio-based materials, or the future of chemical recycling? Okay, then I would like to thank you all for joining today. And as said, Eric Chambost or myself, Frank Krabbenborg, are available for questions in a later stage, either by email or by contacting our communication department.
So I've just posted in the chat my coordinates if you want to bookmark, and Frank, maybe you can do the same as just to send it.
Okay.
Feel free. Yeah.
What should I do, Katja? I mean, once Frank is done, I'm done. Yeah, but I cannot write. I mean, I don't see the left pane.
Yeah. Katja. So I Frank, don't worry. I did it for you.
Okay,
I've posted your coordinates. You're welcome.
Okay. Yeah. Thank you, Eric.
Yeah, you're welcome.
Driving success together.